Okay, hi, good morning. So this is made Setenforce be with you. There's going to be a lot of references in this one. So let's just get on with it. Who am I? I'm old enough to be grumpy at new technology, and I hated containers. I kind of still dislike them. I work at Red Hat, and that means everything's containers. I was a developer many years ago, and then when I switched into database engineering, I had to start working with Docker. And working with Docker meant I had to go into what I didn't like. I ended up working at Red Hat now, where everything is container-based, and we have a desktop edition now that is container-based. We have obviously servers container-based, so I had to eventually get into that. What I'd like for you to get from this talk is to go from this demographic. I do not use containers, which is 46%. The 85,000 responses on the Stack Overflow developer survey just recently. I'd like you to go into this demographic. Whether you try it for development, testing, production, or just outside of work, at least you've tried it and have an educated opinion whether you like it or not. Why am I here? My boyfriend really wanted to go to this conference and didn't invite me, so out of spite, I submitted a talk and it got accepted. So this is why I'm here. This is Neil, by the way. He's very excited about this conference. It's very nice. Yes. Where am I going with this? We're going to talk about containers and content, vulnerabilities, and exploration. Anyway, container content. Well, actually, a container is just a sophisticated use of namespaces, which is something in the Linux kernel, and it's there to isolate processes. So basically, you have a certain set of container kernel features, and those are isolated. They don't talk to each other, or shouldn't, but they are isolated. You can isolate them. And a container is basically just that. So if you want to, after this talk, eventually start with containers, and you don't want to use Docker, you don't want to use Podman or any other runtimes, you want to just start from scratch. There are many, many tutorials on the internet that you can just containers from scratch, and several really good ones where you can just have a few command line commands, and you'll end up having your own containers. Obviously, this is not advice for production. C-groups is another type of namespace, and it allocates the resources. And then, of course, the file system. These all make up a container. Container contents, this is from containers.info. Or no, this is actually from boringisc.cool. They're two very good sites explaining containers and Kubernetes. And here you have, on the top, you have C-groups, and on the bottom, you have namespaces and how they work together. They're controlled by a process group. This is basically a container, like the deep inside of it. It's not very complicated when you get into it. It's very easy. If you've been a sysadmin, it's just a bunch of commands to create an isolated process that can run stuff in it. So, and then there's container runtimes. So you don't have to create it all from scratch. Those are, for example, Docker and Podman. But you can create it from scratch, and it's important to do. Every time if you use a cloud, you're probably better advised to, at some point, have done system administration on your local server, because then you know what's happening. Otherwise, if you start doing cloud stuff, it's just the same as if you suddenly start using jQuery and have never used JavaScript before. Okay, let's go straight into the vulnerabilities. Who knows about the February vulnerability in containers? Okay. Who works with containers, actually? Who has tried them? Okay, and the ones who didn't raise their hands, can someone just say, this talk, is it interesting for you because you develop? Hands? Or do you just want to see because you didn't want to go to the beer farmers? Okay, good. Okay, so the CVE is the run C container breakout, yeah? It was discovered in February. And it allows you to execute malicious code in containers. It allows you to escape the container and has access to the host file system. How this happens? Here's from the bugzilla.redhat.com. You can find other sources as well, but Red Hat has a good security team, and obviously, since we do the infrastructure around it, we'll have a lot about the vulnerabilities. It says, a flaw was found in the way runc handled system file descriptors when running containers. A malicious container could use this flaw to overwrite contents of the runc binary and consequently run arbitrary commands in the container host system. How this happens is you have to download it basically says that it needs minimal user interaction. That minimal user interaction is just you download a public container image which has malicious code in it. Otherwise, it can't happen. Here's an excerpt from the actual article on zd.net, zd.com. And it says, while you should run SE Linux, it's set on by default in Red Hat. Many sysadmins don't run it because it's difficult to maintain. And it really is. But once you realize how it's done, it's not as hard. It's just like a bit like doing a zone file somewhere on your DNS service. It's once you learn how to do it, you know how to do it, obviously. It's not hard after you've learned it. And the container vulnerability is blocked through correct use of user namespaces. I'll get into what that means in a bit. Also, the Docker package. When people say Docker, there's two. There's the open source variant, which is the Moby engine, and there's Docker. Docker itself, it depends on how you set the namespaces, on whether you're vulnerable at all. And also, if you put SE Linux in enforcing mode, it's not a problem at all. So while they hyped up this vulnerability, it wasn't actually one. It depends on which operating system you use and which runtime you use in terms of how the permissions were set. But it wasn't just run C, which means Docker and Podman that were affected. It's also LXC and it's Apache Mesos. So basically everything that somehow runs containers, they check this through before everything gets attached into the right namespaces. You execute the code and then you can escape it. It's hard to do, and I have a link to a demo where you can try it yourself at the very end. Okay, so this is what the Bugzilla looked like. A flaw was found in the way runcc handled system file descriptors. This is just for you to see how the actual vulnerabilities get reported. And further down, this is just a screenshot of the top of the website. If you go further down, you have all the comments. It's really interesting. So if you are into security, these are really valuable things of trying to figure out how it works deep down in infrastructure. If you're not doing forensics or other investigative types, and you're using more infrastructure, this is a good way to start. So in one of those comments, it says, this vulnerability is mitigated if SE Linux is in enforcing mode. And in enforcing mode is, for example, a prerequisite for the OpenShift container platform or for the platforms that use container orchestration. Then, further down, you'll see that atomic host, for example, is not affected by this. Does anyone know atomic host? Okay, so it's an immutable operating system, which means most of the operating system is actually immutable, which means you cannot write to it. It's a read-only operating system where only, in this case, only /home and /var are writable, which means even if you do have malicious code, it's likely to not be able to do anything with it. It depends on what exactly the malicious code is doing. But in most cases, immutable operating systems save you from security problems. I'll explain. So the terminology, which is just names people made up, and we have to learn them by heart and then pretend they're smart. But in reality, people do just come up with things, and then we learn them. So none of this is something, you just learn the concepts, you learn the terms, and then suddenly you know things. This is what I was always annoyed at, when people start throwing around abbreviations and things and names, and then, it's better to explain things from the start. So runc is just a thing, it's a CLI tool, so you use it on the command line, it spawns and runs OCI containers. OCI is Open Container Initiative, and it's basically a standard. It's done by the Linux Foundation. It's a standard for creating containers and how the image specification, build specification, so that basically now you can use Docker, you can use Podman, and they all work with each other. You can, for example, use Podman, which is a container runtime without a daemon, and you can use it with Docker files to create and to manage containers, which is really nice. So yeah, standards are important in this case especially. So from this vulnerability, we had runc. It's a CLI tool response containers. We have SE Linux. SE Linux is it's an additional security control. It helps you isolate the processes, basically the deployed containers in the host, and you set labels. It's a labeling system more or less, and it has policies. So you set the label. You'll say container _t, and then you set the label that this can be called by container underscore runtime underscore T, and otherwise container runtime T only has access to that. So there are policies which define which label has access to what, and you have labels. That's basically what SE-Linux is. It's just very complicated because you define it for every process. So in Apache, you'd have HTTPD underscore T, and then the runtime in the user space. So you have the kernel namespace and you have the user namespace. And the problem with a lot of vulnerabilities is if things are allowed to get from the user namespace into the kernel namespace, that's where you get into trouble. So the way to enforce SE-Linux on your system if you use Linux is sudo setenforce 1. To check whether it is enforced, you'll type get-enforce 1, just get-enforce. And for SE status, this is what will show you the status of your SE-Linux. And we also have our SE-Linux coloring book. You can download it on the link below, or just, search engine it. It's very nice, and it explains SE-Linux on a very good level. We've handed these out at conferences. Unfortunately, I don't have anymore. But yeah, you can just download it. It's fun. We have these for container commandos as well. So we have 3 different types of coloring books. Just to learn containers, to learn SE-Linux, and just, yeah, it's cool. Okay. So terminology-wise, SE-Linux was the security control layer, and we had runc. Next is atomic host, which is just one of the many immutable operating systems out there. As you know, Red Hat has acquired CoreOS. CoreOS has Container Linux, which was immutable, and we also had atomic host, which was immutable. Now we're going to have Fedora CoreOS, and we also have RHEL atomic host, RHEL CoreOS. So, and then there's others. There's, for example, Endless OS, which are targeting developing countries, and they're helping them so they basically make laptops with their own operating system, which is Endless OS, and then they help developing countries by making these laptops available. And when you don't have Wi-Fi, for example, or just internet in general, you have your snapshot of your system, and then whenever you get to an internet, you can just update easily. And the way Atomic Host works is that it uses RPM-OS3, and libOS3 is kind of like Git for operating systems. You can rebase to a new snapshot and redeploy. And if something's not working in the update, you just fall back. So you roll back, and after you've rolled back, you can then, when you know the update's repaired, go back into it. It's just like Git and branches. Okay. So user namespaces, I've tried to explain that a little bit with the namespaces. You have the kernel namespaces, you have the user namespaces, and you basically make sure that access is only granted where it's necessary. Okay. The takeaways for the container vulnerabilities, just for security and beyond in general. Read the manual, always read the manual. And it's the same if you use a cloud. If you, for example, when I used to set up Redshift, which is a database or data warehouse on AWS, you always read through all the manual. Don't just set it up and then deal with it. This is the same where all the vulnerabilities with default passwords come from. People just set up something, follow a tutorial, and they actually deploy it in production. So always read the manual, always make sure that the security policies are in place. And that's basically all from the takeaways. We're not done with this talk yet. And don't forget to update your system regularly. It's really important. And if you have an immutable system, then it's easy to roll back if something goes wrong. That's one bonus. If you don't update, there was another vulnerability, which was in Kubernetes in November 2018, so just recently as well. Who knows about this one? Okay, cool. You can easily be hit by malicious attacks and you don't even know about them. So this special vulnerability, for example, you can't really do forensics on it. This is from the actual issue on GitHub, linked on the bottom right. There's no simple way to detect whether this vulnerability has been used. So basically, they have access to the API. It can be an anonymous user because you use APIs. And you cannot distinguish the authorized and correct requests from the malicious ones because it's just not in the logs because it's a valid thing. So what happened is there was a privilege escalation. So you'd call the API and it will get you to another API and another API. and then you can compromise pods who are running collocated on with one host, because usually you have a machine and it has several pods, several groups of containers running. And then if you escape one container, you have access to everything. And that way you can also exploit environmental variables, secrets. Secrets are basically just passwords. Just that's what they call in some of the environments. So this was a very bad vulnerability. And yeah, it's fixed now in Kubernetes, but you never know what's not fixed. Okay. Exploration-wise, so we've done a bit of the container contents and we've done a bit of the vulnerabilities, at least in terms of understanding what's going on. Let's go into exploration. So platforms, which is what you use and what you develop for. We have then containers from scratch, and we have container runtimes and container orchestrators. Those are the things that are basically used mostly in infrastructure right now. Platform-wise, on that same Stack Overflow survey, we had over 67,000 responses. So people, more than half of the people develop professionally for Linux. After that, Windows. And then within those two, also for Docker in AWS. So those are the four main things people develop in and for. When they use their own laptops, this is what they use mostly, Windows, and then kind of evenly distributed between macOS and Linux-based. So they are not working mostly on the thing they're developing for. Let's go to the most loved ones. So Linux is very loved, which is nice. And then we have Docker. I don't know why that's loved, but it's there. And Kubernetes. They're good to use. They're easy to use. And it's just that it's a bit of a learning curve at the start. And then we have the wanted ones. So people want Docker. People want AWS and Android and Kubernetes. People just want to develop for that. But most of the people are just like, if you're a JavaScript developer starting out, people will tell you to use jQuery. And this is the same thing here. You have to understand the details and really know what's going on. Do you really need containers? I talked to a lot of people who don't like containers, don't think they need them. So let's take a quick intro into, do you actually need containers? No. If you're working alone, so if you're developing on your own, you don't need containers. It's nice because if you download stuff, then you can just download the container image, for example, and then work on that. But you don't need it. If your team's really small and your machines are all set up for the same development, you have all the same tools, you also don't need it. And if what you're developing doesn't need to scale, if you're just developing for this one little company that's only going to use it internally for their accounting or something, you're not likely to need containers. And also you need some time for retraining and proper training, which means if you suddenly use a new technology, you will need to learn about it. You can't just go, one of the team can't just go off and learn about it and then deploy it and no one else knows about how to use it. What we did, for example, in some companies, we also had people developing in containers and then pushing that code into a non-containerized pipeline, which also works. If you're comfortable around containers on your own, then you can simply do that, and even if your company doesn't use the containers. Maybe if you're working alone and want to hone your skills, you want to be employable, fast, you'll just put any container runtime on your resume. If your team is likely to get bigger, it's also very useful. So in the first teams, we used Vagrant and Docker, which was very annoying to set up, and stuff always didn't work out. Nowadays, things are really easy. As in, nowadays we just have a README on GitHub. We explain the exact steps to set things up, and you'll have the exact same system as the person who's been there for 5 years. And then you can just really focus on the code instead of on the setup. If you also can deal with the added complexity and retraining skills, then maybe it's for you. Unless your team's cloud native, which is another funny term that we use a lot right now. So cloud native means you have all the people who are already trained for using the cloud, and you're using the cloud full on, which means you're either in a public cloud like AWS, or you have your private cloud set up, or you have a bit of both. So, hybrid. When you really need containers, you should think about getting them is if you work in a large team or across different teams. So, for example, we have desktop team, server team, security team. We have so many teams that all work on some specific part. and then you will need containers. It makes things so much easier. Obviously, if you're using the cloud, it makes a whole lot of sense, because you have more control over what you're doing and what you're pushing, rather than having to focus on what image you're actually using in the cloud. If you're in testing, it's super useful. You can just have your database spun up, quickly test against the database, and then shut down the container. So it's very useful for a from-scratch database that you want to keep using. Also for a stateful one, you can keep the container running, test against your database, and then purge it all or leave it on, depending on what you're testing. It's very useful. Also, if your application needs to scale and you know that you have this one container, then you just use your platforms. Suddenly you'll have 20, 100, 1,000 machines. It's easy because you don't have to take care of it. You just develop against this one container, push it, it's done. This is very useful. If you want a clean system after trying out some new things, so if, for example, you're on desktop and you have to install Python 2, Python 3, Go, and Rust, and you really don't want these to be on your system because it makes it bloatier, then you can also use containers, which is nice. Okay, common workflows. The way a lot of people at Red Hat work who are directly developing for Kubernetes or for the immutable hosts. These are direct quotes I got from two of my colleagues. One works inside Docker containers and says his local environment, he just basically uses your local environment settings and file system, pipes those into a Docker container, which is easy commands. You just basically look up how to pipe those via Docker run parameters, and then you'll have your system inside a container. You can play around with it, but you're not infecting your own host. And some of us are using OS X, for example. So yeah, you can use a Docker container on OS X and still do all the stuff you're doing for your Linux systems. Another interesting workflow is, so someone wanted to use Podman inside Podman. Podman is a container runtime. This is the same as if you use Docker inside Docker. The way Docker and Podman vary. So a container runtime is a wrapper around these basic container concepts, right? It's a wrapper that's already developed for you. You can do it yourself, but it's just going to take a long time, and obviously you're then a one-person show running the whole thing. If you use an established runtime like Docker or Podman, for example, then you will have to you learn those commands like Docker run, Podman run. Some people even alias, so you have alias Docker Podman, and then they will just continue using Docker run, but in reality they're running Podman behind it. The thing about that is, so most tutorials are for Docker, obviously, because it's the more common thing. But it has a daemon running, so it's a single point of failure. If you use a Docker daemon that you need to run in order to run Docker containers, you cannot, it's a single point of failure and it's big. Whereas in Podman does not need a daemon. Both can be run root without root now, so unprivileged, which is really nice, which means if you use root inside the container, you are bound against your user namespace inside your container. So when you use root inside the container, in reality, you're not using root on the host system, which means you avoid a lot of the security problems you'd have even if you run malicious code inside the container. So definitely, if a tutorial tells you to run anything container runtime privileged, don't do it. And if you have a specific case, like you want to run Docker inside Docker and you need to run it privileged, you can test it, but don't use it in production. So this person specifically, for example, wanted to use Podman inside Podman. So we have Silverblue, which is a desktop operating system, and it uses a Fedora toolbox, which is basically, it's an immutable operating system, and it has a Fedora toolbox, which is a Podman container, and in that container you have your own operating system that you can develop against. If you want to use Podman inside the Podman, it doesn't really work. So one workaround is to replace user bin Podman, which is what happens when you type Podman, and just replace that with flatpak spawn host sudo Podman, and then pipe the arguments into it, which then creates flatpak spawn, creates a Podman container, so it runs the process for Podman on the root on the host system. So basically you just pipe it onto the host, and from there create one, but can continue working in your Fedora toolbox. It's a little complicated when you've never done it. It sounds a bit complicated, but once you get into it, it's easy, just like everything else, or at least, yeah, it's easy, maybe not simple. One way we call the desktop and workflow usage is pet containers. So when you work inside your development, you'll say pet container. So my pet is doing this, or I developed this in my pet. Whereas the server thing is cattle. So it might not be very vegetarian to use these phrases, but cattle is how you would call containers that run at scale and where they auto-scale. Whereas your pet is your personal thing that you use on your own node, whether that's desktop or server, and then develop against it. One type, so common sense security. We do not use container images from untrusted sources. If people tell you to download it, it's cool for your own fun, it's good for your own testing, but as we've seen, there are vulnerabilities, hard word to say. So there are vulnerabilities, and we need to understand that if we just download something from the internet, I mean, you will probably know, but if you just go to any developer who's not very into security, and a lot of them are not, if you just tell them you have to create your own container because you cannot trust the source, they will usually be very angry at you. I've tried. Yeah. So make sure you run your containers unprivileged. So no root access. Do not run them as root. Very important. And Setenforce 1. If you use a different system, there's UpArmor for Ubuntu and Debian, I think, and stuff. But yeah, at Fedora, we use SLinux, and I think a lot of other distros use SLinux as well. And make things immutable where possible. So if you can use operating systems that are immutable, that's also very good, obviously, because if you have malicious code and you can't write to anything, then it's just code. And definitely set limits and alerts on CPU consumption, because there are also, it's not just about your own data and about your own system. There are also cryptocurrency miners that are basically inserted into container images, and they will just use your hardware to mine from the container on your hardware. So, and you won't know. It's very hard to do digital forensics on this type of stuff, especially as we've seen with the Kubernetes vulnerability from November. So definitely set limits and alerts, which if you use the cloud, you can easily do. You can just set it in degree. That's a bit easier than if you have your own on-premise hardware. And definitely check your logs regularly, even if some things won't show up because some vulnerabilities are like that. You have to check your logs regularly for suspicious activity, but you'll know that if you're a sysadmin or have done anything similar to that. Okay, let's go to the future outlook. Just in terms of what technology is where it's heading. So we have the immutable underlying operating systems with automatic updates. And that's exactly what CoreOS and Container Linux did, and that's what AtomicOS did, and that's what EndlessOS is. So a lot of the infrastructure developers are heading towards immutable, which also means that they can provide security updates really fast, because they know that the system cannot be different than this. It's easier to develop a security update. You don't have to wait as much. You just push the security update and you know it's fine and it's going to run. It's also easier on sysadmins because they know nothing can go wrong. Stuff that can go wrong is inside the containers, but that is contained and it's also not affected by the updates. For example, you can have on your system, on your host, you can have Python 2, and then in the containers you'd have Python 3. And they both don't talk to each other, it's fine. So when you update, it's really easy. So get into the immutable operating systems, check them out. For desktop, we have less individual security issues, more like big bangs, distro agnostic, where we had this container vulnerability where it just affected almost everything. But only if you use containers in root and if you didn't have SLinux enabled. There were so many ifs that you had to do to actually get to this container vulnerability. This is also when there's news about some vulnerability, we probably know that it's going to affect a very low percentage. And just like Todd before in the keynote said that, if we have the proper procedures, the stuff first is very unlikely to happen. And if it happens, you have the procedures to resolve it quickly, or at least try to not be blamed too much. On the server, we have one config to rule them all. So that's one future outlook that where we're heading in general with infrastructure is, for example, we're currently working on the machine config operator, where you just define some basics. There's also Ignition from Container Linux, which we also continue using, where you just define all the things, and then this auto-scales. It creates VMs and just auto-scales. Creates, and it's all with the same configuration. You type it out once, and you have your kettle spawned. Okay. And now this is Playtime. If you have a laptop with you, you can test this out already, or when you get home. This is actually really fun, and you can basically test what happens if a container was to escape confinement. So this uses Podman, and yeah, if you just want to test out this vulnerability that happened in February, this is the code you can do it with. So it's just easy and simple for you. We also have github.com/containers, where you'll find Podman and Builder and some demos and docs, and so github.com/containers is where it's at in that regard. Yeah, this is my ending slide. And yeah, are there any questions? Yes.
So, the key areas for a developer who's unfamiliar with containerization, what would be the top few things for them to learn to move into developing in this type of space?
It depends in that sense that when I started doing sysadmin, I really went deep into it and spent 40 hours, like I think half a week, 40 hours did the night through, and just learned everything on the Linode library, but like deep down stuff. So it depends on what kind of learner they are. If they just want to go straight into acting, they will probably just use tutorials, which are a double-edged sword because they tell you to just download this image and then work on this. And when you get into the habit of doing that, then yeah, that's probably not useful. So it's hard. If normally you just say use the tutorials that are out there, and there are so many. It depends on whether they want to use Docker or Podman. I'd say Podman just because, we're working on it and it doesn't have a big daemon, so it doesn't have a single point of failure in that sense. But Docker is just as fine. It's containers. If you use containers, you have an easier workflow once you learned it. I'd probably just really do the start containers from scratch thing. If I was to advise someone on learning containers, I'd say go to your search engine, Google for containers from scratch. There's one Eric something, and he has a very good post on using containers from scratch. There's also Liz Rice, who has several videos on it, but the Eric post is the best on the containers from scratch. And I've just done that, for example, and some other tutorials for containers from scratch. It's super easy. It's actually really fun, and that's how you really learn it. But first they need to learn Linux, because containers are Linux. So they need to learn Linux, and if they don't know Linux, then getting into all of the things is hard. So in your hypothetical scenario, do they know Linux? Okay, containers from scratch then. And then after that, any tutorials with the added knowledge of security, which is important. Any other questions? There was one. Okay. Yeah, I mean, really just the tutorials on the main page for whatever one you're using, or talks. There are several talks out there on YouTube that you can just Google for. Personally, I just like a good blog post that explains everything to me, and then just go ahead and use the examples on that. And once you know that, it's easier for you to get into it, yeah?
So I know, like, in a crowd like this, we're all going to be like, yes, build containers from scratch. It's great fun. But most developers and things are most likely going to be using kind of pre-built containers and things like that. Do you think there's any way to kind of make developers not do that and just encourage them to be more active in learning about them more?
Well, there are your own registries, right? If you're talking as your own person, or if you're talking as your company. If you're talking as your company, whoever is promoting the container thing, if it's not already a thing, needs to know about registries and image registries, where you as a company build your own images, and then you tell new developers or existing developers to just download that image and you know it's safe. So that's basically the most important thing, image registries. There's several out there that you can also host on-premise, so you don't need to go to some website third party. You can just host everything on-premise.
Yeah, thanks.
Yeah. Yeah.
So I'm not a developer or anything like that, but in the organization that I work for, one of the things that concerns me slightly about containers is about managing secrets. Mm-hmm. And I was just wondering what you think is the best way of managing secrets between containers. Is it using something like Docker secrets, or sort of setting yourself up something yourself like HashiCorp Vault, or using something like OpenShift? What would you recommend?
Since I work for Red Hat, I'd recommend OpenShift, but but you know, everything has their secret management, and for whatever you're using, there is going to be a best way to do secret management. And if you use something like Ignition or whatever, you will have your config files pointed to somewhere. You just have to make sure that, which has happened many times on GitHub, for example, companies host their things on GitHub and then they also upload their secrets. So that has happened, and this is bad. So obviously for secret management, make sure if you host the code in a private repository but it's out there, make sure it's safe, encrypted or something. So in the code, if you are a developer, you will have a config file with all the secrets inside. Make sure it's encrypted and decrypted inside or something like that. But that's also the from scratch approach. You should actually just use the secret management from the platform you're using. If that's OpenShift, you'll have a way. If that's Docker, there's the Docker secret. So there's just, for every platform you won't use Docker secrets with, like another runtime and platform you're using. So that isn't really an answer to your question, because it depends on what platform you're using. Yeah, sorry. Any other questions? Or about anything containers or infrastructure stuff? Or cloud? No? Okay, well then thank you, and have a great day. Thanks.